Okay, we are going to get started here. So before we start talking in depth about the volume of a sphere, I want to do a little bit of review first. So in the chat, or message me in the chat, or shout it out, tell me some things you know about a sphere. Round? Yeah, very nice. It is round. How many dimensions? How many dimensions? 3D. Very nice. Awesome. A 3D circle. No sides. No sides. And I see one base in the chat. It actually, we say there are no bases. Is a sphere a polyhedra? Yes or no? No, it is not. Not a polyhedra. Or not a polyhedron, however you want to say that. So, I want to introduce a new definition here, or a definition here as well. So if I have a normal circle, what is the name we have for the distance from the center to the outside of the circle? What do we call that segment there? A radius, exactly. So we can also extend our definition of a radius to 3 dimensions. If I have my sphere, around kind of like that, and my center of the sphere, the distance from the sphere center to its outside is also a radius. That'll be important later. So, last time we used cones and cylinders and some of our relational solids, our special models, to derive equations, to derive volume equations. Today, we are going to do the same thing. We're going to use some of our solids to derive equations. The two main solids that we are going to be working with today, we're going to work with a cylinder again. And this time, instead of working with a normal sphere, those can be a little unwieldy. We're going to work with a hemisphere instead. So we're going to conduct this investigation very similarly to last time. So take a second and on your own paper, record how many spheres or how many hemispheres it would take to fill our cylinder. Once you have a guess on your paper, send me a guess in the chat and I'll record some of them down. Awesome. So I see quite a few here. So I've got 0 coming in. I'm not sure how that one works, but that's okay. 3, 4. What other guesses do we have for this? 4 again. Okay. So, like any good scientist or mathematician, now that we've made our predictions, we got to test them. So I'm going to be using rice like we did last time. And let me get my tops off. There we go. Okay. Move the rice into the photo, into the image. Okay. Got my hemisphere here. We're going to fill this with rice. Usually 2 or 3 spoonfuls gets the job done. Okay. Pour that in. You look in the cylinder, we still have quite a bit of blank space left, like a Taylor Swift song. So we're going to have to fill another one. All right. Full hemisphere. Pour it into the cylinder. We've still got room left. Let me grab the lid to make our demonstration a little better here. You can see there's still a little room for rice to move. So let's try it one more time. All right. Got our rice packed in there. And then pour it once more into the sphere. Okay. And that looks a lot more full right there. Let me cap a lid on it. Oh, if you look here, our cylinder is completely full to the bursting point, not moving at all. So we can stop our process here. So we used 3 hemispheres to fill the circle, or to fill the cylinder. So, looking at question 3, feel free to shout it out or message it in the chat. How many hemispheres does it take to form one sphere? Awesome. Yeah, exactly. 2 hemispheres. 2 hemispheres equals 1 sphere. Awesome. On question 4, what fraction of the cylinder is filled by 1 hemisphere? So, how much of the cylinder was filled by just one of our hemispheres? Feel free to shout it out or message it in the chat. Awesome. Yeah, see it from a couple people. So 1/3 of our cylinder. Oh, it's the wrong blank. Oops. 1/3 of the cylinder equals 1 hemisphere. Okay, awesome. So question 5. What fraction of the cylinder is filled by 1 sphere? So this question takes questions 3 and 4 and combines that info together. Awesome. Yeah. I see a couple people with it in the chat. 2/3. So 2/3 of a cylinder equals 1 sphere. Awesome. Perfect. Okay. Our last question, number 6. Based on the above observations and our knowledge of a cylinder's volume, generate the volume formula for a sphere, showing all of our work. So we know from question 5 that a sphere is equal to 2/3 of a cylinder. What was the volume formula we had for a cylinder? Feel free to shout it out or message it in the chat. We had one formula that was base area times height, but we could be more specific with that. What was that more specific formula we've been using for cylinders? Yeah, very nice. We know that our cylinder volume is equal to pi r squared times h. So we can say that our sphere volume is equal to 2/3 of that. 2/3 pi r squared h. Okay, awesome. Now, we just have one little problem with this formula. H stands for height, and there's no good way to measure height in a sphere, right? Looking at this, there aren't any like flat surfaces that we can use. But what we could use is our distance across the sphere, which I see someone in the chat has already messaged the name of this. So very nice. We could use the diameter instead. Our height is the same thing as our diameter. So we can rewrite our equation as 2/3 pi r squared d Do we have a way to express diameter in terms of the radius? Feel free to shout it out or send it in the chat. How many radiuses does it take to make a diameter? 2. Exactly. We can say diameter is equal to 2r. So then we can sub that into our equation, and we get 2/3 pi r squared times 2r. So we can take our 2/3 and multiply that by 2. That gives us 4/3 pi. And then we can take r squared and multiply it by r to get r cubed. So our volume formula for a sphere, V equals 4/3 pi r cubed. Now, this is a really nice formula. Does anyone want to take a guess why this is such a nice formula? Feel free to shout it out or send it in the chat. How many measurements does this formula need? How many different measurements do we need to work with that one? Two. Yeah, we need a radius measure and we need a height measure. How many measurements do we need to work with this formula down here at the bottom? We just need one measurement. So you only need one measurement for your circle, for your sphere, sorry. One measurement. That makes this formula really nice and easy to use. Okay. So that is all the work we're going to be doing on here today. So feel free to take a quick screenshot of this or take a picture of your work and turn it in. This will be what you can turn in for the 11.8 discovery activity. So take a picture of this, turn it in, and this will be guaranteed points for the day. After you have turned in your activity, I would get out your volume foldable, and we are going to work to fill out the last slide in it. So I'll give you a couple seconds to do that. Okay. We only have 2 examples to work today, and then I'm setting you loose for work time. So if I can have you open up your foldable to our last tab here, we have our sphere examples. In the top, we want to fill in our formula. V equals, and then we're just going to put our 4/3 pi r cubed. That's our formula. That's as tough as it needs to be. We're going to try this on a couple ones. Find the volume of the sphere using 3.14 for pi. So first things first, do we know the radius of our sphere?
Yes.
Yes. And what is it?
6.
6. Okay, we know our radius. That's all our formula needs. So let's just plug that bad boy in. We take 4/3 times pi times 6 to the 3rd power. And you're going to want to put that in your calculator, doing it as much as possible all at once. So 4/3 times pi times 6 raised to the 3rd power. Oh my, light's washing it out, something horrible. Hit enter. And we want this rounded to the near, oh, I forgot to use 3.14 for pi. The problem tells us to use 3.14 for pi. So make sure you're doing that. And it will spit out 904.32. 904.32 centimeters. And what do we do to our volume units? Feel free to shout it out or send it in the chat.
Cube them.
Cube them, exactly. Yeah, so 904.32 centimeters cubed. Okay. All right, we got one more example here. Find the volume of the sphere. We're going to use 3.14 for pi, rounding to the nearest hundredth if we need to. So, what is our radius in this problem?
8.
8. Interesting. Okay, I hear a couple people saying 8. So, what we have to be careful with here is that 8 refers, to this entire line. And that whole line's not the diameter or the radius. We only care about half of it, right? So that means, like Adriana said in our chat, our radius is equal to 4. That's a common little trick that these problems are going to use, trying to trap you. So we know our radius is equal to 4. So we can plug into our formula. V equals 4/3 pi r cubed equal to 4/3 times 3.14 times 4 cubed. Plug that into your calculator. And mine spits out, once we round, approximately 267.95 units, or sorry, we have feet. We take feet cubed. Okay. That is a sphere problem. Something to note, the reason we know this 8 feet corresponds to the diameter is because our dashed line was across the entire figure. If we look at our earlier one, we know that the 6 is the radius because it's only half here, half of our figure. So something to keep an eye out for when you're working problems. That concludes our lesson for today. This is all the new material for your high school geometry class. So congratulations on finishing all of that up.